Hey everybody, this is Larry. This is me going over Q4 of the bi-weekly contest 45. Um, I was a little bit slow on this one, but still, yeah. Hit the like button, hit the subscribe button, join me on Discord, and let me know what you think about this problem, which is the maximum number of events that can be attended to. I actually don't remember the first one. I remember the name enough that I probably solved it, but I don't remember it. So I definitely was starting from scratch when I worked on this problem. My Just to go over my initial thoughts because maybe it's interesting, maybe it's not. If not, then just fast forward a little bit. But my initial thought was that I can do some kind of sweep line algorithm, right, and some kind of binary search on the previous things, but I just couldn't figure it out how to do it quite right. That was basically my idea. So if you look at when I solve it live, I have sorted lists for that reason. And then the second thing that I noticed after I look at constraints more, which is here, was that k times n, where n is the number of events, is 10 to the 6. So that's an interesting constraint. I definitely took a little bit of time trying to figure out if I could do dynamic programming, and I think maybe, not quite sure. I think there may be a way to do it with dynamic programming that requires some sort of day compression, because this is up to 10 to the 9. You could probably squeeze that to n, where n is the number of elements in the array. And I think I didn't do any coding for it, but I was trying to figure that out for about 10 minutes. And at the end, I also just had some debugging issues with off by ones, and off by one and a copy and paste error that kind of cost me a couple of minutes. I probably could have finished top 25 if it weren't for these silly mistakes, but that's okay. I mean, it comes and goes. But yeah, so how do you do this problem? So in this problem, I at the very end, my last thought was kind of going back to sweep line, and what is a sweep line, right? And how? Well, a combination of two things: greedy and sweep line. And sweep line is way often greedy anyway, even if it's not explicit. But the way that I think about it is, okay, so what is a sweep line algorithm, right? Sweep line is basically looking at this example for a second. I know that's harder to look at now that I'm highlighted, but you can think about a straight line that goes on the timeline vertically, and then you try to move it from left to right one space at a time, or one endpoint at a time, right? So that's basically the idea. And once and I think during the contest, and now I try to think through, well, what does that mean once I go from left to right, right? What does it mean for me to kind of go sweeping these events, which is something that I call a lot. And the thing that I noticed was that here for this problem, let's say I look at event 2, right? Well, at the beginning of event 2, you can't do anything because no other previous events have been done, right? So, and then the next event, so the first event is actually event 0 at time 0, and then the second event is at event 2 at time 1, and then the third event, maybe a tiebreaker, but then the third event is at time 2. Well, time 2 is a little bit weird, right? Because now there are two things that happens at time 2. One is that the event 0 is now event 0 can be used, right? So then now we kind of release that to the public, and then the second part is that well, now there's a new event, and then now you can ask a question of, well, can I use previous events? So that's kind of the idea. I'm gonna actually, I know that I'm gonna try again, but now with Microsoft Paint. Let me pull out the paint so that I could kind of visualize it a little bit. That's a little bit of an awkward thing, but give me a second to set that up. Why is that so big? Hang on a second. Okay, so now so let's say we have a couple of events. I'm just going to draw them like as boxes, like that. And let's say that for the purpose of this thing, we sort it by the starting points so that it looks like this, right? Kind of. Oops. And the thing is that, okay, so now we have a vertical line, as we said, which is what we do for sweep line. Let's say we are here, right? Let me use another color. That color is kind of terrible. Let's say we're here at the sweep line. Well, okay, actually, there are two types of events. Let me clarify before I do this, right? Well, there's the end of event, which is kind of confusing. Let's say here, right? Well, what does this mean, right? This means that for this incident, this event, now this event can be used by everything that that can be used in the future, right? So that's what the end of the right side of an interval, that's what that means. And then there's the other type of event, which is the beginning of an event. Okay, right, the next one is going to be this one, which is the beginning of an event, right? And here for this event, that means that this event does not overlap with any of the previously processed event, right? Because here that this event overlaps with, let me change the color again, this one overlaps with this one and this one, but everything before the purple that we processed is good, so that we can use, for example, this orange. So this box can actually use this one and this one. So that's basically the idea behind the sweep line. And we'll go over the code, and I think during the code it may be a little bit clearer, but that's the idea, right? Is that it's you kind of sweep from left to right. The two kind of events. You have an end, you have the right side of an interval event, which means that, okay, this box is now good for us to kind of use. And then the beginning of an interval event, which means that, okay, for this, this box, we can use previous boxes that we processed. So that's basically the intuition behind this problem. Let me kind of now go back to the code. Okay. Yeah. So that's basically the idea. And from that, it just becomes greedy. And the other thing that I talked about earlier was that noticing the constraints are a little bit weird in that k times n is equal to 10 to the 6. So that means that n could be really big, but then k is small, or k times n is 10 to the 6. So they're both reasonably big, but no matter what, k times n is 10 to the 6. I want to put emphasis there just for whatever, but yeah. So here, so how do we process these, right? So now there's two types of events, and depending on for sweep line, this is how I process it. I put all the beginning and end points of the event into I put all the beginning of the events into an array, and then I sort them. So now events will contain all the beginning endpoints, all the beginning endpoints of the events that happen, right? And then now for each event we do a couple of things. I'm going to explain this a little bit out of order, because I think it makes a little bit more intuitive sense. But yeah, so please, follow me, and if you have questions, again, let me know. But yeah, so for each event, we we keep track of the beginning point and the index. We actually I don't think we use x actually, but yeah, but now given this point, everything that's in okay, so I have to explain best. That's my fault. I didn't. Yeah, but best is equal to the best. Oh, sorry, the maximum value. So this is actually a little bit like dynamic programming. The maximum value where we best of I. Yeah, best of I is where we use I events, right? So this is basically an array that I used the default dictionary, but now that I think about it, this could have just been like 0 times k, like a length k array, or k plus 1 maybe. But yeah, but this is the maximum value where we use events. So here, now going back to this for loop, and then going to this for loop, we just basically go, okay, for the max. This is kind of like dynamic programming. The way that I think about it when I was writing it is the maximum value where we use events is basically the maximum value where we use I-1 events and using the current event, right? So that's basically what this for loop is trying to capture, is that we go all the way up to k here because for each k we want to go, what is the best way to use one previous event, or one event, right? Well, the best way to use one event is to use 0 previous events and use this current event, and then the maximum, best way to use 2 events is to use 1 previous event and the current event, and so forth, right? So that's kind of the idea. This is where we keep track of every possibility, right? And then what we do now is that here, what this code does is we, because this is the endpoint, right? So this is the endpoint of the current box that we're processing. So we want to process in the event index, right, which is the input list, right? And then here we want to make this event valid at the endpoint of this event, right? And then we push it to a heap just so that it remains sorted by that endpoint. But I pushed the heap 3 values, and the 3 values are the endpoint, the endpoint of the event, the number of events used, and then just the value, right? So basically, what this part does is that it, going back to the drawing for a second, what this part does is that it goes, okay, like let's pretend for a second we're processing the green arrow, right? So we're processing here this box. So then now what we're saying is that when we get to this endpoint here, we want to process the results here. Otherwise, you're going to get mixed answers, right? So that's basically what this code is saying. It's saying that, okay, when we get to the endpoint, we want to process this result for this for t plus 1 number of events, right? And then now that we do that, we just now this heap thing hopefully makes sense, which is that, okay, we want to process all the previous endpoints that happens before this event, right? So basically what this heap does is that it processes all the previous endpoints that happens before this event, meaning that okay, going back to the, I have to bring this drawing a lot, looking at the green box, now we just, there are a lot of previous purple lines, so we want to process the purple lines so that we can greedily choose the best one for this current number. So that's it's almost like a delayed update, if you will. And here, we have the t that is used, which is the number of events that is used for this, and here is just the value given that. So we pop it off the heap, and we sort it by the endpoint, which is part of the input, and then that's pretty much it. We take the, we just update this to match is either this value or not, and we also want to update the answer just in case that this was right. And then at the very end, we want to process everything that's left in the heap, because at the very end you have just endpoints kind of hanging around, and that's basically the idea here, and that's pretty much it. And then we obviously still take the best answer, but that's pretty much it. So it's greedy, it's sweep line, there's heaped, it's a lot of different things. So what is the complexity of this, right? So the time complexity is a little bit easier because we only use a best dictionary, which goes only up to k. So this is O of k, if you will, and we sorted, but that's not space, and we also have a heap somewhere, and a heap, the number of elements in this heap will be at most n times k. So so that means that for space, it's going to be O of n times k, where n, of course, n is number of events, and k is the input. This is, of course, pseudo polynomial, because k is an input integer. So what is the time complexity, right? Well, we definitely, let's go for it one by one, right? So we look at the number of n elements, and then we sort them. So this is going to be at least O of n log n so far, and then this thing, right? This thing, we have an O of n loop, and then for each of n loop we do k things, and for each of these k things, it takes log of n k times, right? So this is n k times log of n k, right? Yeah, because again, the heap can have at most n times k elements, so therefore it's just log of that. And this also, for each element, because that's at most n times k element, and each element can only be popped once, it's going to be log n k. And that is actually the, I think that's the final complexity. It's just going to be this times nk log nk. And obviously this gets dominated by the nk times log nk. And that's pretty much it. And again, n times k is 10 to the 6. So this is going to be fast enough for this problem, which is actually kind of running it kind of tight for Python, but maybe they are a little bit loose on the edge cases for this one. But yeah. That's all I have for this problem. Let me know what you think. Let me try to find a good place for you to snapshot or whatever. Let me make this slightly smaller so you could kind of look at the code on one page. And of course, this is my contest code, so you can just look at it there. I don't think I modify anything significant other than the comments. So yeah, that's all I have for this problem. Let me know what you think. You could watch me solve it live during the contest next. I definitely kind of go through all my thought process. Not verbally, but like what I said earlier. Let me know what you think, and I will see you. Let's see. I have an idea, but I don't know. I feel like this is DP, but I can't do it. How do I want to do it? So to start. Can we normalize? Should know this one, but I'm struggling a little bit. Because it's just DP, but in a funky way. So basically, I don't know how to do it. Oh, whoops, what did I do? That works, right? People have gotten it. Okay. Actually, this isn't even. Does this make sense? No. This is just a number. It's okay. Push that. So that's n. And t plus 1. That's interesting. Okay. This it's not right at all. This overlapping thing is a little bit weird, but okay. That's just wrong. So basically that's two, okay. That's weird. I feel like I'm close. One's in the heap. That's fair. So here the previous is thing, but then it puts these things. Okay. Oh, I see. Whoops. That is just a silly mistake. Cool. Hey, thanks for checking out the video. Let me know what you think about this problem, anything at all. Hope you had a great contest. And you know, as I always say, stay safe, stay healthy. You know, to good mental health and take care of yourself. I'll see you next problem. Bye bye.